Sorry for the interruption. I am continuing the derivation from the previous video. That is, we know the values R bar and R bar. That is R1 bar plus R2 bar, R3 bar up to Rn. Okay. Similarly, R1, R2 up to Rn. En this one. Okay. So after multiplying, we are getting each term we will multiply with another term. Then we will get it as R1 bar dot into R1 bar plus R1 bar dot into R2 bar like this. We are multiplying with another term. Then finally we have R1 bar to n minus 2 bar, R1 bar Rn minus 1 bar plus R1 bar into Rn bar. So we are multiplying up to 3 term preceding to this Rn. That's why we are considering this one. So similarly for R2, R2 bar Rn minus 1 plus R2 Rn. Okay. So we are multiplying up to Rn bar, R1 bar plus Rn bar, R2 bar, Rn bar, Rn minus 2 bar plus Rn bar, Rn minus 1 bar plus Rn bar, Rn. Okay, this is the whole term that we are taking. We know that the dot product of other two component is 0 except this term. Then this can be written as R square is equals to summation of I equal to 1 to n. In general, I am writing this one Ri square. These are same Ri, R1, R1, R2, R2, R3, R3, Rn, Rn. This is a square term. It will comes into exist. Second term we will consider next. We are generalizing. This is a long equation. We are generalizing this one. 2 into summation of j equal to 2 to n Ri into Rj plus R1 into Rj. Two into summation of j equal to 3 to n R2 into Rj. This will continue up to 2 into summation of j equal to n minus 1. We are considering here n Rn minus 1 minus 2 Rj. We are considering up to n minus 1 term. Okay, because Rn we are already considered, right? It is included. Then we have to consider up to n minus 1 term. J equal to n, n to n, n minus 1 to Rj. Okay. Then after this we are summarizing to get reducing. We can get it as summation of I equal to 1 to n ri square plus 2 into summation of I equal to 1 to n minus 1 j equal to I plus 1 to n rj, right? Okay, this, as I said, ri bar and rj bar are magnitude of ith and jth gem factor. Okay, so now we say that the atom is moving parallelly or in opposite direction, but in real life the atom will move in certain any angles. So considering the angle of movement, then the random walk means the square displacement random walk is given as r square equal to I equal to 1 to n ri square plus 2 into summation I equal to 1 to n minus 1 j equal to I plus 1 n rj cos theta ij. So theta ij is given as angle between ith and jth gem factor. So this is a generalized equation. Okay, I will give a small example for this one. If a particle is there, consider this is a particle, it will move from r1 to r1 r2 r3 r4 then finally r5. So the net displacement is this much, from here to here it is given as r. Then this mean square displacement can be written as summation of I equal to 1 to 5 ri square plus 2 into r1 square dot into r2 so this is simple one, r4 into R5. Okay, plus R2 into R3, R2 into R4, R2 into R5, R3 into R4, R4 into R5. Sorry. Okay, this is the mean square displacement of the after fifth jump. So, as I say, as we know that we are considering the movement of the particle in the solids. In solids, all jump length are equal. That means Ri equal to Rj equal to Rn equal to lambda. I am considering the lambda as a jump length. That means if a particle is there, if you take any particle, the jump length is same throughout the solid. Then this term R square is written as n lambda square plus 2 lambda summation I equal to 1 to n minus 1, j equal to I plus 1 up to n cos theta ij. Okay. Then by taking a common n lambda square 1 plus 2n summation I equal to 1 to n minus 1, j is equals to I plus 1 cos theta ij. Then we are taking the average of these things, because we need to calculate the average mean square displacement, not only mean, average of this one. Into n minus 1, j is equals to I plus 1 to n cos theta ij. The average, we are considering the average value. Then we know that the average of cos theta ij is 0. Then cos theta ij average is 0. Then the equation will reduce to n lambda square for solids. So mean square displacement, average mean square displacement for the solids is given by n lambda square. Two conditions should be considered. That should be random walk. All atoms should randomly walk there, and jump length should be same. That is lambda. So we are considering the root mean square. Displacement is given by root mean square, correct, is equals to root into n into lambda. So this is very crucial conclusion that we are obtained. So it has more significance in many places. I will take an example and I will explain, then we can understand. During carbonizing, the time taken as 3 hours, that is 10 to the power of 4 seconds. The carbon atom makes 10 to the power of 10 jumps per second. Carbon atom makes about 10 to the power of 10 jumps per second. This means this is the frequency. Then we have n equal to 10 to the power of 4 into 10 to the power of 10. That means 10 to the power of 14 jumps it will take. If we consider lambda equal to 0.1, jump length is 0.1 nanometer, that is 10 to the power of minus 10 meter. So if you are just consider the normal average mean square displacement, average net displacement, then we can have 10 to the power of 14 into 10 to the power of minus 10, that is n lambda. Without taking a root mean square, only we are taking a mean square displacement, then we have 10 to the power of 4 meter. That means almost 10 kilometer, which is practically it's not possible. By if we consider the root mean square displacement, then we have 10 to the power of 4. It's not a root. Then if you take a root for this one, it will become So if we consider the root mean square formula, we know that root of n into lambda, that means root of 10 to the power of minus 14, 10 to the power of 14 into 10 to the power of minus 10. That means here it is, finally it will remains minus 7, plus 7, into 10 to the power of minus 10. Finally, we have minus 10 to the power of minus 3 meters, which is, we can explainable distance. Mean square displacement is 10 kilometer, whereas a root mean square displacement is 10 to the power of minus 3 meters. So in practical, we know that this is impossible. The 10 kilometer of sample is not possible, but we can say 10 to the power of minus 3 meters can be carburized after the 3 hours. This is the importance of a root mean square displacement. Thank you.